ఐఎమ్ ఆడిబుల్ అండి. గుడ్ మార్నింగ్ వన్ అండ్ ఆల్. ఐఎమ్ ఆడిబుల్ అండి. వినబడుతుందా? హలో 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 వినబడుతుందండి? ఐఎమ్ ఆడిబుల్లా? Hello. Now I am audible. Please reply. Okay. No problem only. Hello. Hello. Okay. Okay. So, okay, we will start today. After that, your voice came. We will continue here. Today, we can discuss it some more important here. is a simple group. Simple group I am telling today. Some more important first units. Simple group means a group G is said to be simple if G not equal to E and G contains no non-trivial. Anyone tell me non-trivial? Yes, I am audible. Anyone speak? Anyone speak?
Yes, sir.
Now audible. Okay. Okay. Yes. Yes. Okay. So what is the meaning of non-trivial? Anyone tell me non-trivial? Non-trivial or proper? Normal subgroup, that is E. What is E? What is E? Normal subgroup of. So this is a E and a G, and the group are only normal subgroups of. This is called as, we can define as simple group. Then estimate the number of abelian groups of order 3600. Justify the answer. So 3600. What we have to write 3600? Anyone tell me? 3600. What we have to write? So 3600 we can write here. This is 2 power 4, 3 power square and 5 square. We have to write directly. We have to check it with the numbers, the number of non-isomorphic. You have the number of, yesterday I told isomorphic, the number of isomorphic abelian groups of order. Of order we have to write, that is a 422. 3600 we can write here. P of 4 and P of 2 and P of 2. This is maybe written as. So that is a. So we can so where P and denotes is the number of partition of n, we can write here. So therefore, it is 20 non-isomorphic abelian groups of above order. This is the call as 3600. So this is one, and an ideal of the ring yesterday I told. So ideal of the ring R is said to be a maximal ideal. So maximal ideal provide that I not equal to 1. So therefore, whichever J is not ideal. So R with the I subset of I subset are equal to j subset are equal to r. So then we can write I is equal to j, or j is equal to r. We can write this one for the definition. I'm audible? Please. I'm audible, Andy? వినబడుతుందా నా వాయిస్? So therefore, define a Boolean ring. Define a Boolean ring and prove that every Boolean ring R is commutative. What is commutative?
Unmute.
Okay, now okay. Now okay, Afros.
Yes, sir.
So now define a Boolean ring and we have to prove that every Boolean ring is commutative. So we have to take here a ring. A ring R is called a Boolean ring. So we can write here x square is equal to x for all x belongs to R. This is a statement. Then we have to take the proof here. Let x comma y belongs to R. Then x plus y belongs to R. And by the definition of Boolean ring, so this is, we can take that, we can write here x plus y whole square is equal to x plus y from the Boolean ring. So therefore x plus y whole square is equal to what is here? X plus y, but x plus y whole square is equal to, we have to write x plus y into x plus y. So therefore we have to write this one. X square plus xy plus yx plus y square. This is a definition. So therefore we can write here x plus xy plus yx plus y. We can write it this condition. You can write this condition. This implies that therefore x plus y is equal to x plus xy plus yx plus y. How will this one? So the cancellation loss. The cancellation loss in R comma multiplication we obtain x plus y, sorry, xy plus yx is equal to 0. You can take this is the condition number 1. So we have to put x is equal to y. So therefore we can write in place of y. So in this then x square plus x square is equal to 0. So therefore we have to write here then x plus x is equal to 0. So therefore that means x is equal to minus x from there. For all x belongs to R, we have to write here. So therefore by the first condition, xy is equal to minus x. Xy is equal to minus x is equal to, we have to write yx. So therefore xy is equal to yx. So therefore R is commutative. I understood? Please respond.
Yes, sir.
Yes, all of you speak once again. Okay, now you are audible to me. Okay. Let f subset of Afros, tell me.
Yes, sir.
Now all of you speak.
Yes, sir.
Now okay.
Yes, sir.
Rajeshwari okay.
Yes, sir.
Not
Thank
my
you, sir.
side. It is hoster. So now I am going. First two problems I told. Any doubts? The Boolean ring, and this is a abelian group and simple group. Are you understood, all of you? Let f subset of k and alpha belongs to k be algebraic over f. Note చేసుకోవాలండి ఆటోమేటిక్ గా మీరు. Let 0 a0 a1x So P of X, A0, A1X, and so on. X minus n, x power minus n be the minimal polynomial of alpha over f. So then we have to prove that f of alpha f degree of P of X and f of alpha is equal B0, B1 alpha, Bn minus 1 alpha, n minus 1, B1 Bi belongs to F. So therefore, conversely also, prove that if f alpha f, then phi is all algebraic over f. This is a statement. Now now we have to take the proof here. Suppose we can take alpha is over f and P of X is equal to A0, A1X plus X power minus n is the minimal polynomial of f. Then A0, A1 alpha, an minus 1 alpha, n minus 1. So this is the minimal polynomial over f. So then we have taking A0, A1 alpha, A2. So therefore, the condition up to go an minus 1 alpha, n minus 1 plus alpha n. But hence we are taking alpha n and alpha m minus 1. We are taking here. Each of alpha n power minus 1 can be written in the form of that is A0, we can write B0, B1 alpha and so on. Bn minus 1 by Bn minus 1 alpha. You can write it or not? We can write it or not? All of you? Okay, are you all of you? We can write it or not?
Yes, sir. Written.
Yes, sir.
Yes. So therefore B0, B0, B1 alpha and so on. Bn minus 1 alpha n minus 1. We can write here that condition. So with Bi belongs to F. With Bi belongs to F. And hence So is f of alpha for any f of x belongs to capital F of x. We can write this condition. Now we have to put G group, put G here, put G here, B0, B1 alpha, and so on, plus Bn minus 1, alpha n minus 1 by B. We can write the above condition. So therefore, clearly know that G is a subring of a K. We know that the A and B were taking here. We can take that clearly. We know that G is a subring. G is a subring of K containing F and alpha. What is F and what is alpha? What is F and what is alpha? Tell me what is F, what is alpha? Tell me.
Alpha is a algebraic over.
Alpha is a
Algebraic over of F.
Yes, I am audible clearly. First of all, tell me.
Yes, sir.
All of you unmute your. Then I will ask. I did not unmute anyone. నేను ఎవరిని మ్యూట్ చేయలేదు. So therefore, the continuation clearly G is a subring of K, F and alpha here. So define here sigma stands to G by F of X. It may be written as F of A. Therefore, sigma is an epimorphism, and f of x belongs to kernel sigma. This may be written as f of alpha is equal to 0. Therefore, we can write p of x by f of x. So that is f of x belongs to. We can write this one. This is f of x belongs to p of x. This is a fundamental. I know already. You know that fundamental theorem of. You know that fundamental theorem of homomorphism. So therefore, f of x by p of x, that is similarly equal to is a group G. Now therefore p of x is a normal polynomial of alpha. So normal polynomial alpha, therefore p of x is irreducible. So that is a by known theorem. We know that p of x is a maximal ideal of f of x. So therefore G is a field from the above condition. So therefore we have right here G is equal to f of alpha. G is equal to f of alpha. We have to write. Now audible?
Yes, sir.
Those who want,
Yes, sir.
yeah. Those
But
who
sir,
want,
one thing, sir. Now, as soon after the voice completed, again it is going to unmute only, sir.
okay, I'm checking. Now it's okay, na?
Yes, sir. Now
Yeah, yes, sir.
If any unmuted, please ask, please SMS, WhatsApp message. Sorry.
Yeah, I
Chat
sent,
box
sir.
me, then I will do it.
Okay, sir.
Right.
Thank you, sir.
Yes. G. So therefore, G of alpha. So similarly, we have to take here. So now P of X is the minimal polynomial of alpha. P of X is irreducible. So by the theorem of G is alpha. So therefore, also we can take here 1 comma alpha n minus 1 is a basis for G over is a group over F. So we can write here F of alpha and F that is equal to n, that is degree of P of X we can write. So this is a statement of conversely also we can write here. So conversely also if F of alpha F is equal to m we can take here. So then 1 alpha square and so on alpha power m must be linearly. What is linearly independent? What is that meaning? What is that linearly independent? What is what is independent? Linearly independent. So is there. Now check.
yes, sir.
Okay.
Yes, sir.
Okay, sir.
What is the meaning of linearly independent?
It's equals to 0. Means non-trivals.
Now, what is the meaning of non-trivial?
At least it has one constant, not equals to 0.
Exactly. So therefore, there is a linearly independent. So therefore, m plus 1 is therefore you can write here C0, C1 and CF not all 0. We can take that C0 plus C1 alpha power m is equal to 0. Therefore, all F we can write here this condition in this one. Yesterday we tell the R by U is also commutative. Yesterday we learned people of maximal ideals also. The finite extension of the fields and the polynomials of the Einstein criterion. So we can take that one to one. Now we are let f of x is equal, let f of x belongs to z of x be a primitive polynomial, then prove that f of x is reducible over Q if and only if f of x is, what is the meaning of irreducible? What is irreducible? What is reducible? What is reducible?
Decreasing.
So reducible over, what is Z? What is Z?
Set of integers.
Set of integers. Very good. Yes, yes. Proof. F of x is usable Z, then clearly f of x is reducible over, what is Q?
Rational number, sir.
So therefore f of x is reducible over Q. But suppose you have to take here f of x is reducible over Q. Then we write. Please mute అండి. మీరు ఎవరైతే మాట్లాడదు, please mute. So reducible over, then reducible over, then we can write here f of x is equal, we can write here g of x into h of x, where here g of x and h of x are constant polynomials. What is the meaning of constant polynomials? What is a constant polynomials?
Sir, which cannot be changeable.
Yes, the constant polynomials here. So therefore we can write here, we can write g of x is equal to a by b, and g1x a1b into g1x, where we can write g1 of x belongs to just primitive. Yesterday I told primitive, and h of x is equal to c by d of h1x. So therefore h1x also belongs to z. It is a primitive of a comma b comma c comma d belongs to z. We have to write here. So therefore bd into f of x, bd into f of x, so the ac into g1 or g1x h1. So bd into f of x, ac into g1x into h1x. Comparing the constants, we can get that. Comparing the constants, bd is equal to ac. So therefore, since we can take here f of x and g1x and h1x are primitive. We are taking here. So therefore f of x is equal to g1x and degree of g1x is equal to degree of g of x greater than 0. So degree of g1x is equal to degree of g of x greater than 0, but degree of h1x is equal to degree of hx. So degree of hx is less than 0, greater than 0. Degree of g of x greater than 0, degree of h of x, degree of hx is greater than 0 or less than 0. Therefore,
Greater than 0.
For here f of x is reducible over z. We are taking here. This is the one of the definition of all maximal ideals to and prime ideals of the ring z of integers. You have to. This one. All of you understood?
Yes, sir.
Yes, sir.
Yes, sir.
If E is a finite extension, if E is a finite extension of a field F, prove that E is a simple extension if there are only a finite number, if there are only a finite number of intermediate field. What is the meaning of intermediate fields? Of intermediate fields. Between F and E. Anyone tell me intermediate fields? I am audible?
Middle one. Intermediate.
Yes, sir.
Tell me.
క్లాస్ లో ఉన్నాను చెప్పు.
Mute చేయండి sir. What is the definition of intermediate fields? So which is on turn on extension K, F is said to be an intermediate field. Intermediate extension, intermediate sub of extension. So given field extension L by K larger, L is K vector space. So intermediate, that is a vector space K, we can take that one. So that is between F and E. So therefore we can take the proof here. Let f of x be the polynomial let f of x be the minimal polynomial of alpha over f we are taking here. But E is equal to f alpha, but some alpha belongs to E is a simple extension. Is a simple extension of f. Suppose K is a subfield of E containing, we are taking here, there is F. So now alpha is algebraic over. Now alpha is algebraic over K, and let g of x is equal alpha 0, alpha 1x, and so on, alpha n minus 1, x power n minus 1. Maybe written, this is alpha is algebraic whenever K. So we can write alpha 0, alpha n x, and so on, alpha n minus 1. We can write it or not? By the minimal polynomial x power n with the minimal polynomial alpha over, we are taking K here. But clearly we know that g of x by f of x in k of x and k of alpha we are taking here. This is meant to be treated as n. So why? Because we write a k dash here. So f of alpha ij comma alpha and up so on alpha n minus 1 we can write here. So therefore these conditions now get g of x belongs to k dash. Now we have to take here. Now we get g of x belongs to k dash x and k dash subset of k and k dash alpha is k dash is equal to, and we can write it or not. Gx belongs to k dash subset of equal to k dash alpha k dash is equal to n. We can write it or not.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Please respond. E is equal to f of alpha subset k dash alpha. So that is a f of alpha subset of equal to k dash alpha subset of equal to k alpha then subset of equal to e alpha. What is that value? That is what f of alpha subset equal to k dash of alpha subset of equal to k alpha subset of e alpha. What is that value? We can write e.
E is equal to
అయినప్పుడు రాసుకోవచ్చు కదండి.
yes, sir.
So therefore, hence k dash alpha is equal to k alpha. We can write also. So therefore, k alpha k is equal to k dash alpha k dash is equal to n and k dash subset k, and hence we get that, and hence we get that k is equal to k dash. We have proved that k is any intermediate field in that form. So therefore we have to write here k is equal to f of alpha 0, alpha 1 and so on alpha n minus 1, alpha n minus 1, alpha 0, alpha 1, alpha n minus 1 decay. Therefore g of x is equal to alpha 0, alpha x, alpha 1x and alpha n minus 1, x power n minus 1 we are taking, that is x power n at the condition is the divisor of f of x, the divisor of f of x in k of x we are taking here. So therefore there are only a finite number of monic polynomials. To divide f of x, we get that the intermediate fields are, then it is a monic polynomials. Therefore, divide the intermediate fields are finite or infinite. Finite or infinite?
Finite.
Finite, sir.
But tell me.
Monic polynomial, no, sir.
Yes, only polynomial. Therefore, finite. Very good. So we can take the conversely.
Sir. Sir.
Tell me.
Sir, please ఒక్కసారి పైది స్క్రీన్ చూపించరా సార్, స్టార్టింగ్ క్వశ్చన్ పార్ట్. Yes, 1 second, please.
Okay.
Okay, sir. Thank you, sir.
So conversely, we can take that. Suppose that the intermediate fields, the intermediate fields between f and e are finite. We shall distinguish two cases. The case 1 we are taking here. Suppose F is a finite field we are taking here. Then E is a finite, I already told. Then E is a finite. And E minus 0 is a which group? It's a cyclic group or not? E is a finite field, then is a finite E minus 0 is a cyclic group or not? Finite field and cyclic group అవుతుందా కాదా?
Yes, sir.
Yes,
Cyclic.
sir. అవుతుంది.
ఎంతసేపు ఆలోచిస్తున్నారు ఎందుకు ఇవాళ? E minus 0 is equal to alpha, then f of alpha is equal to E. Is a simple extension of f. The simple extension of f we are taking it. For each we are taking here A belongs to E. So f subset of f of A subset of equal to E. So therefore T is equal to f of A f, then A belongs to E. We can write it or not?
Yes, sir.
About the conditions
Yes,
we can.
sir.
Since E to F is a finite, we get the T is finite, we can write here. So therefore choose B belongs to E, that B means f of B colon of F, we can write here B, we can take that is the largest number of T for any A belongs to for any A belongs to E. So therefore f of A to F less than, this is correct. F of A colon F less than or equal to f of B F, it is correct.
Yes, sir.
Yes, sir.
Condition for any A belongs to E. Avuna?
Yes, sir.
Yes, sir.
Claim that. We claim that f of B. Suppose f of B not equal to E subject by the hypothesis. We have to take f of CD plus B by D belongs to F. We can write it or not from the above condition.
Yes, sir.
Hypothetical ga C does not belongs to f of B.
Yes,
For C plus B, it is a finite. So B belongs to F. So it is a D belongs to F is finite. We are taking here. So therefore R comma S belongs to F such that R not equal to S. So f of CR plus B is equal to f of CS plus B. We can write it or not? In place of R is equal to S, of R is equal to S, we can write here. So therefore Z is equal, we can write Z is equal to CR plus B. Now CR plus B belongs to f of Z and CES plus B belongs to f of Z. So therefore CR minus S belongs to f of Z. And hence of the above condition we are taking here, C belongs to f of Z. So therefore 0 equal to R minus S belongs to, this is equal to or not equal to?
Not equal to.
Very good. Again, I am writing CR plus B. 0 not equal to R minus S belongs to B belongs to f of Z. Therefore, f of B subset of equal to f of Z we can write here. So therefore also C belongs to f of Z and C does not belongs to f of B. So therefore only we have to took that here, take that here, which implies that here f of Z, f of B is greater than 1.
Yes, sir. Greater than 1.
Greater than.
Greater than 1, sir.
Are not audible, so that's why I asked again. So therefore f of Z of f is equal to f of Z of f of B we are writing here. So therefore f of B is greater than f of B colon of f. So we can contradicts the largest property is f of B of f. So therefore what is E is equal?
Equal to f of b, sir.
Very good. E is equal to f of B because the largest property. So this is the conditions what we have proved for the intermediate field between F and E. Define the concept of ring. Define the concept of ring and commutative ring with illustrations. So therefore, a ring is triple. What is meaning triple? Triple means
Triple means 3, sir.
3 times.
yes, dot. Am I correct?
3 times.
Yes, sir.
3.
A triple is a consisting of a non-empty set. Non-empty set we are writing here R and two binary operations. Two binary operations and dots on R satisfying the following. I'm writing the following condition. I will ask the questions also. R comma plus is a commutative group.
Yes, sir.
Data is a therefore R plus dot is a commutative group. Second one, A plus B plus C is equal to A plus B plus C is associative.
Yes, sir.
Yes, sir.
A comma B comma C belongs to R. Third one,
Additive.
there exists an element R, 0 in R such that
Additive identity.
0 plus A for all A belongs to R. Correct?
Yes,
Yes,
sir.
sir.
For any A belongs to R, there is an element minus A belongs to R.
Inverse. Yes, sir.
To 0 is equal to minus A plus A is equal to 0. Correct?
Yes, sir.
The condition.
Commutative next.
Very good. A plus B is equal to B plus A for all A comma B. Then second one. R comma dot is a semi-group. What is the meaning of semi-group?
In multiplication, it has to be associative, sir.
Associate should be satisfied.
Under multiplication.
All A, B, C belongs to R. The operation is distributive over the operation. Just a minute. The screen is.
Yeah, it's looking blur, sir.
Huh?
Screen is looking little blur, sir.
Oh no, it's stacked.
Okay, okay. Okay.
Here up to the screen will be visible. It is a distributive law. So it is a distributive law for the order of the operation. A plus B dot C is equal to A dot B plus A dot C. And A plus B dot C is equal to A dot C plus B dot C for all A, B, C belongs to R. So this is the conditions for the operation of therefore we are telling. What is the ring? Ring is R triple, that is R plus comma dot is a commutative, that is we can write A dot B is equal to B dot A, all A belongs to R. Suppose we can write, when take the example, let Z be the all of set of all integers. You know that Q is set of all rational numbers. So just a minute.
Okay, sir.
Again, I'm here. So therefore, that I already told it is a semi-group distributive. I told that. Then the operation R dot comma semi-group. I am writing here again. A dot B dot C is equal to A dot of B dot of C for all A comma B comma C belongs to the third condition. The operation is distributive over the operation, that is addition. Over the operation, that is addition. A dot of B plus C is equal to A dot B plus A dot C. Dot C is equal to A dot C. You can write it or not?
Yes, sir.
For all
A dot C plus B dot C.
Already I told R plus dot is just a commutative ring. The operation multiplication dot is A B dot B is equal to B dot A comma B belongs to R. We can write here. Then one take example here. Let Z be the all integers to the set of all rational numbers the or the set of all real numbers. Correct? It is correct or not?
Yes.
Yes, sir.
What is Z? What is Q? What is
Rational numbers.
Rational number.
Z is integer, Q is rational number, R is real number.
Real
Very
numbers.
good. Real numbers.
Rational
Integer.
numbers Q and Z
Q
is
is
integers.
rational number, R is real number.
That is
Integers,
Integer.
sir.
Z is integer.
are all examples of rings where plus and dot are the usual addition and multiplication and use and multiplication. So this is one. So in this case, the ring is commutative ring with identity integer. So the one is being the multiplicative identity. Am I correct or not?
Yes, sir.
Yes, sir.
You can ask doubts any first to third unit, fourth units. I'll clarify.
No, sir.
Another one. Note it, and I will clarify. Prove that the set A n of all even permutations in Sn is subgroup is a normal subgroup of Sn n greater than 1. Then prove that the index of the index of a power n is Sn is 2, and hence an is order 1/2 of n factor. This is the prove that all even permutations is the normal subgroup of n. Therefore, n greater than 1, prove that the index of an is 2, S2n, 2, and n's order of 1/2 is n factorial. We have to prove here. Now, G is equal 1 minus 1 we are taking here. Be a what is the meaning of multiplicative group? Multiplicative group. Multiplicative group.
Commutative sets అవుతుంది sir.
Of integers. 1 and minus 1. 1 and minus 1. So we can,
Okay.
Yes, integers.
consider here as a mapping Sn into G, group Sn into G. Just a minute. So therefore, Sn is into G. So we have to prove that epsilon is homomorphism. Therefore we have to prove that epsilon is homomorphism. What is epsilon? What is the value? Epsilon means it is a less than 1 or greater than 1. I'm asking you only.
Less than 1.
Sigma t belongs to Sn. So we have to take here sigma tau r either both even or both odd permutation then sigma T is an even permutation. Even. So there are either even or both odd permutation called as even permutation. That is here. This is we can write plus or minus 1 whole square.
Yes, sir.
Therefore, epsilon of T. Therefore, epsilon is a homomorphism or not? Plus or this is a homomorphism or not? So this is a, therefore epsilon is a homomorphism. Kernel.
It's not clear, sir.
Huh? This sigma belongs to Sn. Sigma belongs to Sn. Therefore, this is a 1. Sigma belongs to Sn. By this is an even permutation. So this is a even permutation. What we have to write? This is An or not? From the above condition, we are writing these conditions. Sigma even permutation, we can write An or not?
Yes, sir. AM.
For
Even
An is normal. An is normal subgroup of
मैं कल यहाँ ले लेते हैं टाइम इच टाइम
Sn. So therefore,
मैं छोड़े कल दे देती ये ले लो हाँ
Sn contains both permutations. So therefore, this is both permutations called, we can call it as onto. We can call it as onto or not?
yes, sir.
Yes,
The
sir.
fundamental theorem of homomorphism. Tell me, what is the fundamental theorem of homomorphism for group? The fundamental theorem of groups. Kernel therefore Sn by An equivalent to G and Sn by An is equivalent to 2. Why? Because modulus of G is equal to 2. So therefore An is a subgroup. Enta? X enta? Therefore, this is a subgroup.
अगर ये पूरा खराब है देख के निकाल तो था
N is equal to 1 by 2 is power n. So therefore, equal 1 by 2 of n factorial is normal subgroup of. Okay. Ask me. You are asking? Ask me. Any doubts? Doubts, Andy?
No, sir.
R is a ring and U is on ID
दुखा मैं दुखा
of R. Then prove that there is on
हो गया मेरा से पूरा साफ निकला
from R onto R by U. This kernel U. Already yesterday I told this
मेरे
one.
तरफ से
R onto R by U with kernel U. Yesterday I told, but this is another thing. It is a ring of ideal. So the mapping proof the map phi of R to R by is defined. Yesterday చెప్పాను కదా ఇది ఏమిది డిఫైన్ ఏమని రాసుకోవచ్చు phi of a is equal u plus a అని రాయొచ్చా
Yes, sir.
Yes,
U
sir.
plus NH.
నిన్ననే చెప్పాను ఇది
Yes, sir.
so this is u plus a belongs to
R by U.
a comes to r then phi of a what we have to write
U plus B.
phi of b
U plus B.
U plus B.
phi of a plus b
U of U plus A B.
A plus U.
u of a plus b
Plus
correct
A plus B.
u plus a plus
U plus
U plus
we have to write this is phi of a plus
phi of
phi of b so phi of ab is equal to u plus ab then I'm doing addition multiplication u plus a into u plus b so phi of b from the definition phi is 1 and phi is onto or not
yes, sir.
sir.
for the of along is u and epimorphism with kernel u understood
Yes, sir.
the problem
Yes, sir.
if r is a field then prove that
आमा
आधा से में खाली
दो से ना खा रहा
minute
दो से वो में भी आधा आधा खाली में
था
it's only ideals are 0 and r itself. So R is a field that prove that it's only ideals are 0 and r itself here. So then we have to take a proof here. Let a not equal to 0 be any ideal of r, then there exists at least one element a belongs to a such that a not equal to 0. Now a belongs to r and a not equal to 0. Suppose that we are taking here a not equal to 0 ideal of r, so therefore a not equal to 0, therefore a not equal to 0. So therefore a belongs to r, a not equal to 0, the condition. So therefore r being a field, there exists a inverse belongs to r such that a into a inverse is equal a inverse into a is equal to 1. So therefore 1 is equal to a into a inverse belongs to a, that condition. So a is an ideal. A is an ideal of R and 1 belongs to A. We have A is equal to R. So thus only ideals of R 0 and R we can write here. So we have to prove R 0 and R itself. Any more doubts? Ask me. May pass. Any more?
No, sir.
So now very important, one more important question I am telling last. Ask me. Any more doubts?
No, sir.
No, sir.
It will take some more time. So we will next week we will Gallo theory, and some more topics we will cover in the next weekends. Any doubts? Ask me. I will verify.
Sir, starting that's a screen చూపించరా sir? Class starting లో.
Just a minute. This is yesterday's. See here, simple group today.
One, sir. Yes. 1 second. Next, sir. Yes.
Estimate the number of abelian.
Yes. Yeah, this I want, sir. Please. One second, sir. Sir, please. Yeah. Okay, sir. Yes, sir.
Boolean ring next.
Yes, sir. Yes, sir.
Left subset of equal
Yes,
to
okay,
k.
sir. Yes, sir. This I got.
Okay.
Okay, sir. Okay, sir.
Any doubts? Ask me. Otherwise, I will leave.
No doubt, sir.
All of you understood?
Yes, sir.
Yes, sir. No doubts.
Yes, sir.
Thank you. Thank you, one and all.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.